Welcome back. We'll look at another homework question. On page 106 on the textbook, question number 13D, we already discussed the first three questions. So we're moving on to question D. So we have to use the chain rule in Leibniz notation to find dy dx at the indicated value of x. So we have the function y equals u cubed minus 5 u cubed minus 7u squared. And the function u in itself is square root of x, is a square root function, and we're evaluating it at x equals 4. So let's start off by writing the chain rule in Leibniz notation. So dy dx, that's what we're trying to find, is equal to dy du times du dx. Let's substitute y in dy du, so we're differentiating function y, which is u cubed minus 5, u cubed minus 7u squared, in terms of u. So you see that the variables connect, so it's an explicit differentiation. And then we are differentiating in terms of x, the function u, which is x to the power of 1 over 2. So again, direct or explicit differentiation. So let's start differentiating here. So as you can see, the function y in terms of u seems a little bit complex. We have the difference of two terms, which would equal the difference of the derivatives. And so we're going to have the derivative of u3 equal to 3u to the power of 2. So the derivative of the next term, as you can see, we have a little bit of a chain in here, so be patient with that. So we have negative 5, and now we are differentiating this part. So you have an outside function here, which is u3 minus 7u power of 2. So we are going to do the outside first, so the power becomes 1, and then you have u3 minus 7u. And now we'll have to multiply by the derivative of the inside, which is 3u squared minus 7. And this would be just the derivative of this term here. We're going to close the brackets. And then times the derivative of x to the power 1 over 2. This would be 1/2 of x. And remember that this came to the front in here, the 1 over 2. And the power of 1 over 2, take away 1, will be the same as subtracting 2 over 2. So that will make this negative 1 over 2. So negative 1 over 2. Now next we are going to clean up this expression as much as we can. We have 3u squared. And then we have minus 10. And then the product of two things here, u cubed minus 7u multiplied by 3u squared minus 7. And then we're multiplying by, got to close the brackets, by 1 over 2 x to the power of negative 1 over 2. Now remember that this derivative here has to stay together in brackets. So to emphasize this, we are going to keep the entire factor inside these big brackets, and we'll try to bring in the function u, and that is because we need to determine the derivative in terms of x first. And you see that we have x in here, but we have so many u's that need to be replaced. So we'll replace each and every u here by x to the power of 1 over 2. So we'll have x to the power of 1 over 2 for this u here. We'll have x to the power of 1 over 2 for this. X to the power of 1 over 2 in here as well. And now we're ready to rewrite this entire thing. So we have the number 3 to start with, the coefficient 3. X to the power 1 over 2 is squared. And then minus 10. X to the power 1 over 2 is brought to the power of 3 here, and then minus, oops, almost missed this. So we have x to the power of 1 over 2. So we have a 7 in front of it. Close the brackets. So it seems that we're going to need an extra bracket in here as well. So let me bring this a little bit further down here. So we're going to need an extra bracket down here. Oopsie. Just to clarify one more time. So notice that we have this set of brackets. Let me make this different color so we can see it. This set of brackets. So that means that we have u to the power of 3 minus 7u that has to stay inside its own brackets. Okay, and we are substituting the next u, which is in front of, it's to the power of 2, and it has a coefficient of 3 in front of it. And I'm going to make these brackets here orange so that we can see it better. Now, x to the power of 1 over 2 will be squared in here because we have 3u squared and then minus 7. Close the orange brackets. Close the green brackets. A lot of algebra, and algebra will get on the way when differentiating functions always and forever. So x to the power 1 over 2, I'll make this with a positive power. So this is just a du dx. So let's check and see what we have obtained. We're going to clean up this expression. It's going to look a lot nicer, hopefully. So we have 3. Now, x to the power of 1 over 2 squared will give simply x. And then minus 10. Now, notice that here we have to multiply these two binomials. So it is best that we do not bring the 10 in. So we just leave them in factored form. So we'll have minus 10. Let's keep the colors the same. And then we're going to do the blue brackets here, which are x to the power of 2 over 3. And then minus 7x to the power of 1 over 2. And then close the brackets. And then we have 3x to the power 1 over 2, so that this will be 3x, and then minus 7. Okay, so remember that these are our orange brackets, these are our blue brackets, and this is our green bracket. And then multiply by dy dx, which is 1 over 2. And I'm going to write this as square root x because why not? It's easier to evaluate it this way. So it seems that this is as simplified as it can be at this point. And remember that we are trying to find dy dx at x equals, let's double check again, x equals 4. So it's nice that it's a perfect square number because we know that we will have it inside a square root. So the future seems friendly. All right, so we have number 3 multiplied by x, which is 4, and then minus 10. Inside the blue brackets, we're going to have x to the power of 3 over 2. Sorry, I made a mistake here, but easy to kind of identify them when you are evaluating. So 1 over 2 times 3, that's 3 over 2. Very smart, isn't it? So that would be equal to number 4 square rooted to the power of 3. And then minus 7. X to the power 1 over 2 is like square root of 4. And then orange brackets now. We have number 3. X is 4 minus 7. Close the orange brackets. Close the green brackets. And then multiply by 1 over 2 root x. And let's make a statement here that we started with the green brackets. We're ending with the green brackets. And that's the entire expression we have here. We're going to substitute x by 4, obviously. So let's check and see what we get now. Hopefully we haven't missed anything. So we have 3 over 4, which is 12, minus 10. Let's do the blue brackets first. So the square root of 4 is 2 to the power of 3 is 8. So that makes an 8 in there. And then minus. 7 times root 4 is 14. And then let's do the orange brackets. Let's drop the red color actually. So that's 8 minus 14. Let's do the orange brackets. So 12 minus 7, that would make a 5. And then close. And 1 over 2 root 4 would be 1 over 4. Because root 4 is going to be 2 times 2, 4. So we get this. Okay, almost there. So let's simplify again. We have some more brackets. So we'll take care of them. We'll take good care of them. So minus 10. So 8 minus 14, that's a negative 6. And then times 5. And then multiplied by 1 over 4 at the end. And here we go. We have to do the multiplication first. And then we have a 12. Obviously, you can do this very fast in the calculator. So negative 10 times negative 6, that's a 60 times 5, that's a 300. So plus 300. And then take 1/4 of it. So we have 312, and we're taking 1/4 of it. And 4 goes into 30.